Section 2.4. The next transformation that we're going to talk about is rotation. A rotation is when you take an object and you spin it. Now you can spin it clockwise or counterclockwise. So make sure you write this down. Clockwise is when you move something the way a clock moves, which is to the right. So you go clockwise if you move something to the right. If you move something backwards, the opposite of a clock, it's called counterclockwise. So if I take this star here and I turn it, I'm moving it clockwise. That means I'm rotating it. Now if I go the other way, that means I'm going counterclockwise. Here is your key idea on rotations. A rotation, which is your vocab word, or turn, is a transformation in which a figure is rotated about a point called the center of rotation. You can't just turn a shape. You're going to turn it around a point. The number of degrees a figure rotates is the angle of rotation. That is your third vocab word. The angle of rotation is the angle at which you turn something around that point. So I'm going to draw just a diagram to show you how this works. So make sure you do write this down because this is all part of your key idea. So in this problem, you can see that we have a trapezoid that was moved to the right, which would be clockwise. So it was rotated to the right. But it was around this point. These are imaginary lines. These don't actually exist. So we turned it around this point, and we only turned it 90 degrees. So this is a 90-degree angle of rotation. Around right here, which is the center of rotation. Number 1 says you must rotate the puzzle piece 270 degrees clockwise about point P, and we're going to have point P be right here. You don't have to draw this because it's going to be too hard to draw puzzle pieces to fit into a puzzle. Which piece fits into the puzzle? So we have to rotate this 270 degrees. Now I'm hoping that you guys all know what 270 degrees is. 90 degrees would be here. Another 90 would be here, which is 180. 270 would be here. And then 360 is right back to where you started. So if I turn this once, and I'm going to do the best I can at turning this. If I turn this, let's turn it 90 degrees. 90 degrees would be that. So that's our answer then would not be A. 180 degrees would be like that. So our answer would not be B. And then we turn it again. 270, there we are. So our answer would be C. So let's try that one more time. Our original shape was this. Now remember point P, we're going to say was right here again. So if I move this, point P, around point P, so we're starting right here. So we have 90 degrees. 180. Another 90 would be 270. Now if you actually did 360, you're right back to where you started. So our answer is C. Example number 2, you must write this down. You don't need to write the whole thing, just write the points down. The vertices of a trapezoid are W is negative 4, 2, X, which is negative 3, 4, and the Y, which I did not write on here, so I'm going to write it now. Y is going to be negative 1, 4, and Z is negative 1, 2. Rotate the trapezoid 180 degrees about the origin. What are the coordinates? So the first thing you need to do is just make a rough graph of X and Y axes. You don't need graph paper in your notes. So I'm going to first graph the points. So negative 4, 2, that would be 1, 2, 3, 4, and then up 2. Make sure you label. This would be W. Then negative 3, 4 would be here. That's X. y is negative 1, 4, which is right there, and z is negative 1, 2. So we connect these to make the trapezoid. Now this by far is the trickiest thing to do. You want to take this trapezoid and you want to move it 180 degrees about the origin. Now watch my cursor. Here's the origin, right here. So you basically want to pretend you put your pencil right here and spin it to the right. So if you spin it to the right, now I'm going to do this, but if you spin this to the right, it's going to look like that. That's 90 degrees. Then I'm going to spin it again. That's another 90 degrees. That is 180. Now I know your graph's upside down, but this piece right here is what you're going to draw exactly in the fourth quadrant. So if you did it again, that's 270, and 360 is right back to where you started. So if you need to turn your paper to visualize where it's going to be, that's okay. And I actually encourage you to do that if you get confused. But if you turn, let's say, point W, let's start there. If you turn point W, you're going to end up right here. And it's going to be W prime. Z is going to end up right here, which would be Z prime. Y will end up right here, which is Y prime. And X prime would be right here. Whoops, that's not correct. X prime is not there. X prime would be here. And that would be your answer. And once again, if you need to turn your paper 2 times at 90 degrees to get to 180 to see what you graph, that's okay. Now the new coordinates. You have to make sure you answer the question. The new coordinates are W prime, which would be 4, negative 2, X prime, which is 3, negative 4, Y prime, which is 1, negative 4, and Z prime, which is 1, negative 2. And those would be my answers. Our last example is number 3. The vertices of a triangle are as follows. J is 1, 2, K is 4, 2, and L is 1, negative 3. You need to rotate the triangle 90 degrees counterclockwise about vertex L. So this is a little tricky. So we're going to first draw our graph. So now I'm going to graph my 3 points. So J is at 1, 2. K is at 4, 2. And L is at 1, negative 3. And then if I connect these dots to make our triangle, there's our triangle. Triangle JKL. Now this is where it gets a little tricky. This problem, you are not rotating like this. You are not taking this and rotating it like that. You're not doing that, because that would be about the origin. What you are doing is rotating it around this point, which means if you would put your pencil right where this red dot is, and you turn it to the left, because we're going counterclockwise. So if you turn it to the left, what would happen? And you're only going 90 degrees, so it's going to move this way, 90 degrees. So if we move it 90 degrees to the left, J is going to end up, now L is not going to change. L is the same thing, so L is going to be L prime. J, now if you get confused, just look at how many spaces up we go here. So 1, 2, 3, 4, 5, go this way. 1, 2, 3, 4, 5. So we know J is going to be here, and that's going to be J prime. And K is, J and K are 3 units apart, so that would make K right here. And so if we connect the dots, it should be congruent. They're going to be the same. So if you notice, this shape was moved 90 degrees this way, counterclockwise. So it was moved counterclockwise. Therefore, J prime is going to give us a coordinate of negative 4, negative 3. K prime is negative 4, 0. And L prime is the same, which is 1, negative 3.